This problem asks us to consider a phase diagram for a substance and to analyze it pretty thoroughly. First of all, in the diagram there are lots of different labeled points, and in the first part they're asking us what phases are present at each of these. In any phase diagram, going clockwise from left to right, we'll always see solid, followed by liquid, followed by gas. It always goes in that order: solid, then liquid, then gas, in a clockwise order. Other points worth noting, and which will be asked about shortly. The point at which solids and liquids become indistinguishable with temperatures and pressures above that is called the critical point. And at temperatures and pressures above that, in regions way high up, the substance takes on a state of matter called a supercritical fluid, or its plasma. We don't often see that in everyday life. The other point that I'd like to draw your attention to is point E, the point at which solids, liquids, and gases all reach an equilibrium. That point is called the triple point. So in the first part they ask what phases are present at points A through H, and select all that apply. So in point A, we're squarely in the solid category, and that would be the only state found there. Point B is in the liquid area and would be the only state of matter seen there. Point C is right in the middle of the gas region, and that would be the only state of matter seen there. Here's where it gets a little more interesting. At point D, we're at the border between solid and gas. That is, some of the substance is subliming, going from the solid state directly to the gaseous state, and some of it is deposing right from the gaseous state to the solid. So we see both solid and gas at point D. At point E, as I mentioned before, that's the triple point, where all three commonly found states of matter are at an equilibrium. And so at that point, we see solids, liquids, and gases. At point F, we're right on the border between liquid and gas. That would be a point where the substance is either boiling or condensing. So we have both the liquid state and the gaseous state at point F. At point G, we have the solid, both the liquid and gas, and if we could choose supercritical fluid or plasma, I would select that too, but that wasn't one of our options at point G. And then lastly, at point H, it's a supercritical fluid, but our best option given that selection is a gas, something closest to a supercritical fluid. There are other things to identify. It says identify the triple point, normal boiling point, normal freezing point, and critical point. So let's talk about those each in turn. The triple point is where three states of matter, solid, liquid, and gas, are found in equilibrium. So that would be point E. Normal boiling point. Normal just means at normal atmospheric pressure. And boiling, of course, means the transition from liquid to gas. So if we follow the dotted line at 1 atmosphere to the border where liquid and gas are found, we would make the selection, the point at which the liquid gas line, that would be this line that goes between the liquid and gaseous states, is at 1 atmosphere. The normal freezing point, similarly, we're looking at the normal atmospheric pressure, and now we're looking at the border between solid and liquid, because freezing would mean a transition from liquid to solid. So the point at which the solid-liquid line is at 1 atmosphere, so right about there on your graph. And then lastly, the critical point is the point at which liquids and gases become indistinguishable. So that the liquid gas line does have an end point at point G. That point is called the critical point, whereas the solid liquid line extends forever. It would be a line, or a ray, actually, a ray that just keeps going on infinitely. And then lastly, which phase is denser, solid or liquid? Remember how water is the big exception, where the liquid state is more dense than the solid state. Water's phase diagram would look like this, where the solid liquid line has a negative slope. For everything else, for every other substance, the solid liquid line has a positive slope. So what that means is, as pressure goes up, which means as you go upwards on the y-axis, you're packing molecules more tightly together, and upon doing that, for the substance that we're considering in this question, you're going from the liquid state to the gaseous state. Whereas, by contrast, with water, if you're crossing the solid liquid line by increasing pressure, you would go from the solid state to the liquid state. So, in this substance, like every substance except for water, solid is more dense than liquid.